Hello everyone and welcome to Lesson 4. In our last session, we covered the production guides for front and rear cameras. Now, we'll continue with the topic, focusing especially on how to use music features to create your own work. The central idea we operate with is music-driven interaction. Users create sound through direct actions like tapping different grid blocks to trigger beats, bass lines, and melodies in real time. The sound responds instantly, turning rhythm and listening into the core gameplay and creative experience. Music-based content isn't created perfectly in the first try, it's built through iteration. So, how do we build this? It starts by focusing on three pillars: how users interact, what sounds are triggered, and the overall musical experience. First, define the core musical interaction. Describe how the user makes music. A strong bass prompt looks like this. Tapping different areas to trigger drums, bass, melodies, and vocals, allowing users to compose electronic music through rhythm and listening. No music theory required. Once that core loop works, you expand musical complexity. Use a follow-up prompt to add depth. Add more instruments and let users choose a set before starting, giving them creative control while keeping the interaction simple. Finally, to create meaning, add creation ownership. Let users keep their work. Place recorded audio into a dedicated button that allows users to download their music. This methodology allows us to create a wide range of playables, from a quick meme cat choir to soft note touch instruments to dynamic music selectors or even introspective journals like Echoes of the Soul. Let's see these examples one by one. Now let's walk through a real production example, creating the meme cat choir playable. The step 1, the basic idea. What we want to build. We want a game where typing a sentence turning letters into colored, moving notes that fly to meme cats, each playing a musical pitch. Step 2, identify the problems, why it doesn't work well. The first output often fails. Here the cat won't show, and the letters had no color or animation. The interaction was broken. Then step 3, fix the prompt with the key technique. The fix is to be explicitly descriptive. We must explicitly bind visual assets, explicitly bind music attributes, and explicitly describe the animation behavior. This instructs the model on how to connect sight, sound, and action. The process of spotting issues and refining leads us to the powerful method mount-around dialogue-based teaching adjustments. A perfect teaching example has a clear mount-around structure where each change is intentional, guided by music attributes, aiming for a final result that feels calm, coherent, and alive. Let's look at a real dialogue sequence. Round 1 fixes technical blocking errors. Before refining creativity, fix system-level or runtime errors so the experience can run. You can choose between professional editing methods and plain language descriptions when combined with the framing technique, which involves selecting specific areas for modification. This approach helps Loopit pinpoint issues faster and fix bugs more effectively. Always stabilize the system before improving sound or visuals. And round 2 wants to enrich sound texture. The issue is sparse sound and basic visuals. The adjustment focuses on music density and visual feedback. Round 3 addresses repetitive timbre and increased instrument diversity. The focus shifted to variety and style. Round 4 tackles the lack of harmony and atmosphere. For example, this prompt added a keyboard with star effects on touch and background music. This round focuses on foreground versus background sound and emotional continuity. Then round 5 unifies the visual language when the visual elements feel inconsistent or some objects look like they come from different styles. The examples uses a subtle light trail effects on interaction, ensuring all elements felt part of the same calm word. This round focuses on word coherence, and visual harmony supports musical calm. The last one, round 6, it wants to improve musical interaction logic when strings cannot be played together or background music does not start automatically. It focuses on polyphony and natural musical behavior. So what does this example demonstrate? Firstly, music prompts evolve through iteration. Then we solve problems once focused dimension per round, technical, sound, interaction, or visual coherence. And most importantly, in Loopit, music attributes must be audible, visible, and interactive. This is how we make it playable. We start with a musical intention, build the core interaction, and then refine layer by layer, round by round, until the experience is seamless, engaging, and feels truly alive. Thanks for watching.